Can you solve this tricky geometry question asked in SAT exam? We are given 3 identical circles, each with a radius of 1 unit, all touching each other like this. There is also a rectangle that touches all 3 circles externally just like this, and our goal is to find the area of this rectangle. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let us solve it together. But before we begin, let's first mark the centers of the 3 circles and define the dimensions of the rectangle. Let the length of the rectangle be represented by the variable x, and let the width be represented by the variable y. We know that the area of a rectangle is calculated by multiplying its length by its width. So in this case, the area rectangle will simply be x times y, right? Now let's draw a horizontal line parallel to this length of the rectangle, passing through the centers of the 2 circles, like this. Did you notice something? This horizontal line passes through the center of the circle, and each segment from the center to the edge represents a radius. It means this entire horizontal line is 4 times the radius. Radius of circle is given as 1 unit. That means this horizontal side length of the rectangle, which we have defined as x, must be equal to 4 units, correct? Let's keep this here in the corner. Now focus on this vertical side, which we define as y. This line from bottom to the center of this circle represents the radius, so this must be 1 unit. Now let's connect the centers of the 3 circles by drawing lines between them, like this. According to the theorem of touching circles, that is when 2 circles touch each other externally, the straight line connecting their centers is equal to the sum of their radii. But each circle has a radius of 1 unit. That means this distance between 2 touching centers is 2 units. So this side must be 2 units, this is also 2 units, and this is also 2 units. Since all 3 sides of this red triangle is 2 units, this is an equilateral triangle. Now draw a vertical line from the top center to the base of this equilateral triangle like this, and focus on this blue right-angled triangle. Base of this blue triangle is equal to the radius of this circle, so it's 1 unit. Hypotenuse of this triangle is 2 units. Let the height of this triangle be h. As this triangle is right-angled triangle, thus using everyone's favorite Pythagorean theorem, we can write h squared plus 1 squared is equal to 2 squared, or h squared plus 1 equal to 4. Now subtracting 1 from both sides, we get h squared equals 4 minus 1 or 3. Taking the square root on both sides, we get h is equal to plus minus square root 3. Since length cannot be negative, we discard the value of minus square root of 3. So this length h is square root of 3. Again, this line from top to the center of this circle represents the radius. So this also must be 1 unit, right? Now notice anything? This total vertical length y of this rectangle is made up of 3 parts. This one radius on the bottom, which is 1 unit, plus this height of the red triangle, which we calculated as square root of 3, and 1 radius on the top, which is again 1 unit. So y must equal to 1 plus the square root of 3 plus 1, or simply 2 plus the square root of 3. Now substituting value of x and y into our area expression. Area of rectangle equals 4 times the quantity 2 plus the square root of 3. And that is our final answer. Pretty satisfying, right? But wait, before you go, I have one more bonus challenge just for you. Can you find the area of this rectangle in terms of the radius r, instead of using the numbers? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you enjoyed this explanation and learned something new, don't forget to hit that like button, share this with your friends, and make sure to subscribe for more brain-teasing math puzzles. Thanks for watching, and I will see you in the next video.